Okay, welcome back. This is the second lecture on, see, I forgot, 4.7 and 7.6. Okay, so we just finished this example, right? And we saw that if x is approaching 0 on the right side, I end up, right, I use the L'Hopital's rule, and I end up with e to the x over 6x. So when x is going towards 0 from the right side, so this will be a very small number, and the reciprocal of that will be a very big number. Okay, and then when x is approaching 0 on the left side, right, so I'll be getting closer and closer to 0 from the left side, so so absolute value of those numbers will also be very, very small, right, but there will be negative numbers. Then I have 1 over, how should I put it? I don't know. Negative numbers that are getting bigger and bigger, closer and closer to 0, right? Then the answer is negative infinity, right? 1 over such a number, it's negative infinity. Okay, let's look at another example. Quite interesting. Okay, so yeah, the same thing. We need to evaluate limit when x is going to 0, and I have something like this. So 1 minus cosine x over x squared. Okay, so again, we try to analyze it, right? So as x is going to 0, then I have 1 minus cosine of that 0. Then I will have cosine of 0 is 1, 1 minus 1. So this whole thing will, let's just say, approaches, right, 0. And then x squared, of course, if x approaches 0, then x squared approaches 0 as well. Okay, so we have our indeterminate form of 0 over 0, and we can apply the L'Hopital's rule. So I have the limit, and then 1 minus cosine x, and derivative of this, and derivative of x squared. So I have my limit, and here on the top I have sine x, right, because derivative of cosine, negative cosine is negative sine, so it's positive sine because of that negative here, and here I have 2x. So I have the same situation here, right, so I will apply that rule, L'Hopital's rule, again. So I have my limit, x is going to 0, and on the top I have cosine x, and on the bottom I have, where is it, 2. Okay, so now we can evaluate it, right? So if we plug in 0, I get cosine of 0, and that's 1, right, over 2. Okay, so I want to look at this problem a little deeper. So we can say that, let's say that as x approaches 0, it's getting closer and closer to 0, or we can even say x is approximately 0, right? Then we could say that 1 minus cosine x over x squared is close to half. Okay? And then, well, I can multiply it by x squared, cosine x. So I will have 1 minus cosine x is more or less half x squared. And then solve it for cosine x. So I'll have cosine x is approximately 1 minus half x squared. So we can see that, let me rewrite it a little bit. So cosine x, so I have negative half x squared plus 1. Right? So cosine x, we can see that cosine x can be approximated by this polynomial, right? So this is a quadratic equation. It's a parabola, right? That's shifted up, upside down parabola that's shifted up by 1. Okay. So let's write it down. We'll be doing this kind of stuff in later lectures. So let's write y equals cosine x can be approximated. I hope it's two p's. Approximated by, well, you know, y equals negative half x squared plus 1. Okay, so this process is called polynomial approximation. Okay, so we'll be doing this type of approximation with all kinds of functions. Alright, so let's do one more thing about this problem. Let's look at the graph. So when I have that graph of cosine x, so let's say we have 1 here, and then this would be pi over 2 is what? Pi over 2 is a little more than 1, right? So pi over 2, negative pi over 2, pi over 2 here. Okay, so the graph of cosine would look like this, right? And then it goes this way, right, and keeps going like that. Here, the same thing. Okay, but actually, you guys should do it and try to graph it in Desmos, right? Or some kind of graphing calculator or graphing program. Anyway, so here's my parabola, my y equals negative half of x squared. Alright, so if you do it in your calculator or some kind of graphing program, you can zoom on this part, right? If you zoom on this part, you'll see that here, close to 0, those two graphs are basically indistinguishable, right? They're the same. Like, you know, if you zoom it over here, it's just one sitting on top of the other one. So this is my negative half x squared plus 1, and the green one is cosine x. Okay, so that's something we'll be doing in more detail in later lectures. For now, let's do an example that has a slightly different, that, you know, in the indeterminate form. So another indeterminate form. So this one will be 0 times infinity. Right? We suspect that, right, that would be 0, right? 0 times anything is just 0. But let's double check it. Okay, so I have that limit with x approaching infinity, and here I have square root of x times e to the negative x. Okay, so let's do our analysis. So as x approaches infinity, square root of x, right, goes to infinity, obviously, and then e to the negative x. Right, so I have, so that's the same as 1 over e to the x. So if this number grows, right, gets really big, then the whole thing gets really small, right? So that approaches 0. So I have 0 times infinity, or infinity over 0, right? If I put that e to the negative x in the denominator. Okay, so in fact, let's do that. So limit of x, it's going to infinity, and then let's put that e to the x in the denominator, and let's take a derivative of both. So that would be on the top. So I'll have, what is it gonna be, negative, where is that? So it's gonna be 1/2 times 1 over square root of x, right? So it's x to the half, so I put that half in the front, and then I subtract 1 from half, so I'm getting negative half. Half is a square root, and negative makes it a reciprocal, okay? So that's what it is, over e to the x. So now let's put that, let's clean it up a little bit, get rid of that double story fraction. So I have, what do I have? 1 on the top, 2 here, e to the x, and square root of x. Okay, so now this whole thing is going towards infinity, right? So 1 over a big number is a very small number, and then the number gets smaller and smaller, right? Then this number gets bigger and bigger, so that is indeed 0. Okay. There's another set of problems that we need to figure out what to do, how to do. And this one, well, let me give you an example. So this is example 6. So it's limit x is going towards infinity, and then 1 plus 1 over x, power of x. Okay, so you may remember this problem from the class on elementary calculus. You may remember what the solution is, but yeah, I like this problem, so let's try to tackle it. So as usual, we'll do our analysis. So as x is going to infinity, right? So we may think of it like this, right? So I can think of it like, okay, so I have 1 plus 1 over x, right? So I may think of it like as x is going towards towards infinity, right? Then this is going towards 0. Okay, so this, let's put 0 there. Then let me take a different color. So then this whole thing, if this is going towards 0, well, this whole thing is going towards 1, right? But I still have that x here, so let's take red. So now I'm looking at the whole big thing, including that x. So if this is 1, I'm raising it to some big number, but it doesn't matter, right? If I raise 1 to any power, I'm just getting 1. Okay. I can think about it like this, but check this out. So this number, right? So 1 plus 1 over x so this whole thing, well, it's definitely more than 1, right? And then if I raise something that's more than 1 to some, enormous power, well, I'm going to get infinity. Right? So the question is, well, what is it? Is it 1 or infinity? Well, the answer is that it's neither. Anyway, let's try to do it. So I have the way we need to approach this problem. We need to get rid of that. Let's see. It's here, right? So we need to get rid of that x, right? So this x, if we can put it in the denominator, right, that would be great, because then we can apply that L'Hopital's rule, right? We need a quotient, right, of two functions. Okay, so let's try to put that in the denominator. So I'm gonna just rewrite this function as y equals that thing, so 1 plus 1 over x to the x power. So now what I'll do, I'll take a logarithm of both sides, right, this way. So I have this 1 plus 1 over x power of x. This way, right, if you remember the properties of logarithms, I can take that x and put it in the front. Right, so I still have my ln y. Now that x is here, 1 plus 1 over x. Okay, so next step, right, instead of multiplying by x is the same as dividing by 1 over x. Okay, so I have my natural log of 1 plus 1 over x divided by 1 over x. Okay, so let me rewrite it. So I have that limit where x is going to infinity of, and I'm basically taking a limit of both sides, right? So now here I have limit x infinity, and I have my ln 1 plus 1 over x over 1 over x. Now I'm taking the derivative, both numerator and denominator. Okay, so what do I have? So I have limit x going to infinity, natural log of y, then I have my limit on this side, and here, right, so derivative of the outside, so it's going to be 1 over this, so 1 plus 1 over x times derivative of the inside, so that's, what is it, negative 1, well, negative whatever, negative, and then 1 over x squared. Okay, and here, yeah, it's the same, right? So 1 over x squared, or negative 1 over x squared. Okay, that's good, because now we can cancel these, and I have limit x is going to infinity of 1 over 1 plus 1 over x. Okay, so if x is going to infinity, this thing approaches 0. So I have 1 over 1, which is 1. Okay. So let's see, what do we have now? So we have that left side still, right? So limit x is approaching infinity infinity, and now I have that natural log of y equals 1, right? So the question is, right, so what is that y, right? That's what I'm asking. So let me rewrite this here. So natural log, so this is a base of it, right? So this is something I need to find, and this is 1, right? So if I rewrote it in the exponential form, I would have what I have? E to the 1, e to the first power, right? So this is a power, this is the base of the exponent, of this exponent, equals y, right? So you can see that y simply equals e. So that whole limit, right? So let's write it here. So y equals e. So that whole limit that we had at the beginning, so x approaches infinity, 1 plus 1 over x. See, now I don't have space here. Equals e. Okay, but you already knew that, right? Okay, so e is, right, remember it's just a number, it's just a constant, it's 2.71 more or less. Okay, 21 minutes, let's stop here. I will continue.